Hello guys, today we're going to be going over square roots, explain and simplify, and the basics of square roots. Alright, so what is a square root? Square root is when a number that you multiply itself gives you the original value. So, a basic structure or formula we can apply is the square root of x equals y. And we would do y times itself equals x, which we put under the square root. Alright, so how do you solve a square root? And I do want to get a little bit more technical about this because right here I have some very broad terms. So there are going to be different rules and ways you can solve a square root, and really how you do it is up to you. And another thing is memorization, which we'll get into a little bit later. But this is just a broad way to solve square roots and how I do it. So essentially what you're going to do is break the square number into two smaller values. Those two smaller values should be able to multiply to equal the square root. So it's very essential that you know some factors, common factors and stuff like that to solve square roots, or just know like basic math equations that can make a square root and solve for it. Alright, some perfect squares that you can remember and memorize. So the blue is the perfect squares, and in the black we have numbers that essentially multiply themselves to make that square root. So I have 1 to the power of 2. That equals 1 because I did 1 times 1. 1 is a perfect square root. I have 2 times 2 because 2 is to the second power. That equals 4. That is a square root. I have 3 to the second power, which is 3 times 3, and that equals 9. I have 4 to the second power, which is 4 times 4, which is 16. I have 5 to the second power, which is 5 times 5 equals 25. Do you notice a pattern here? Do you notice that I am essentially multiplying these numbers times itself? So like example, 2 times 2, 1 times 1. And I am doing this and I am getting these perfect squares. So yeah, you can, basically a way to get a perfect square root is to multiply a number by itself, and you would have the square root, which is the answer. Alright, so non-perfect squares. Square roots that are non-perfect are irrational numbers. So an example is the square root of 2, or the square root of 3, or the square root of 7, or the square root of 10. These are all irrational and just imperfect, because I cannot do like 5 times 5 that would give me 25. That wouldn't give me 10. If I did 5 times 2, I would get 10, but those are two different values. They're not perfect. I could do 1 times 2 or 1 plus 2, and I still just wouldn't get the square root of 3. I would have to do another way to solve this. Alright. So I do want to go over some radical symbols because these are very important and you should pay some detail to them. So right here I have a positive radical on my left. On the right I have a negative radical. The negative radical will have a negative sign right next to it, and it's very essential you pay attention to those to make sure you are solving the equation right. Alright, another thing you should keep in mind is square root is the opposite of exponents, which is a power. So I have x to the second power equals a, and I have x equals square root of a. These two cancel each other out, and they are opposites. And that goes important with a rule we go over and square roots rules. So you can check that video out, and I go into further depth about that. Alright, so I have example number 1. I have the square root of 8. I know I can break this down into smaller values. So I would rewrite this as a multiplication. So I have 4 times 2. Then for the second step, I want to write it as a square root. So I'm going to put this multiplication under some square rooting. So I have the square root of 4 times 2. I'm going to split the square root up. So I have this 4, right? I know that 4 can be a smaller value. So I do the square root of 4 equals 2. Now I'm going to simplify the square root. I still have that 2 at the top. I cannot forget about that 2. So I would put the 2 on the outside and have another 2, which is from the 4 times 2. And I would put that inside of the square root. So I'd have 2 to the square root of 2. And then if I solve that, I would get 2.83. And you can use a calculator to solve that. All right, example number 2. I have 121 equals something. I know I can break 121 into values, smaller values. But wait, isn't 121 a perfect square that I memorized? Or I can do 11 times 11. That's how I know I would get 121. So this is a perfect square. Our first problem, we had to dissect and find smaller values for the product and break it down. For perfect squares, you do not have to do that. So for example, if I had the perfect square of 1, I wouldn't need another value to solve that. I would just do 1 times 1, and I wouldn't have to do much further with that. So these are pretty self-explanatory problems when you have a perfect value. It is just important you know some factors or even memorize square roots to solve. That's essentially what I did for some tests. Memorization is key. Or just know some simple terms and you could solve it that way as well. Alright, so for example number 3, I have a little bit more of a trickier problem. I have the square root of 968. I'm going to break this 968 into smaller pieces so I can manage it better and solve for it. So I could do 968 divided by 4. 4 is a pretty divisible number and it really helps us get to the root of the problem. So when I do 968 divided by 4, I get 242. So, and then I want to break this down a little bit more. So I'm going to do 242 divided by 2. I get 121. Wait, isn't that a perfect square? I know that 11 times 11 gives me 121. But now I'm going to undo this and multiply it by 2. And once again, to do that, I'm going to rewrite it as a square root. So we're putting this as a square root. So I know I have a 4, I have 121, and I have 2. 4 is a common divisible, likewise to 2. 121, that's a perfect square, and I'm going to stop there because I now have a perfect square. This makes the problem so much easier to solve. So 4 times 121 times 2. Now we're going to separate the square roots. So I have the square root of 4, I have the square root of 121, and I have the square root of 2. These are all separated and put under separate square roots. Now I'm going to take square roots of perfect squares. So that means I'm simplifying these again into perfect squares. So the perfect square of 4 would be 2. The perfect square of 121 would be 11. And the perfect square root of 2 would just be 2. When I do this, I get 2 times 11 times square root of 2. We're going to leave that square root of 2 alone. So now when I do 2 times 11, I get 22. And I have the square root of 2. So essentially, that would be my answer. And if you want, you can solve it like we did the other one. But I'm going to leave this as it is. So I have 22 divided by 2. And do you essentially see how no matter what we do, we break down the square root to find a simple term that can solve it? That's why breaking it down and just going in smaller pieces and working in small chunks is essentially just how you solve square roots. Alright, so thank you for watching. If you have any questions or comments, please leave them down below and I'll be more than happy to answer them. In this video, we went over how to break down square roots, some inverse operations, things to keep in mind, and yeah. So this is Ari, the math tutor, signing out. See you guys next time.